Hi everybody, it's time for StormTracker School. I'm Meteorologist Samantha Mohr, and we're going to talk about thunder today. I hope you're doing really well. I know I'm going to have to reverse this image because it's going to be backwards, so I always have to look and see where that tool is here. There it is. That's the one I want. Okay, now we're cooking. I hope y'all are having a day. I know it's beautiful outside, isn't it? It's just absolutely gorgeous. And we're going to be seeing storms forming. Let's see if we can see. Can you see me? Hi, everyone. It's time for StormTracker School, and we're going to talk about thunder today. I look a little yellow, don't I? Sorry about that. It's all about this technology, isn't it? So we're talking about thunder, and to do some experiments, you may want to get brown paper bag if you happen to have it, because we're going to make kind of the sound of thunder and talk about the physics of air as it expands. And we're going to have some more thunder on our Thursday as well. So we are looking at storms coming in on Thursday that could be severe. If you have a balloon also, a balloon and a way to pop it, that could be helpful because we're going to talk about the expansion of air by heat. And I'm going to go ahead and make sure our web team knows that we're up and running so that they are aware of it. Hi web team, exclamation point. We are in StormTracker School right now, and we're talking about thunder on the 11 Alive Facebook page. Okay, so now they're aware of that. And hopefully everyone can see us. I hope you're having a good morning, everyone. So I think with making the sound of thunder, it's just kind of a fun project for kids. It's fun for adults too. So let's talk about lightning and thunder since we're going to see a lot of it this week. I'm Meteorologist Samantha Mohr. I hope you are doing well. I can't quite tell if there are people with me because I can't see, but the light is blinding me. But we're going to talk about how lightning creates thunder. So we know lightning happens. We heard it the other night. We had that rolling thunder that we were talking about. We had claps of thunder. So why does thunder exist? We know we have lightning. We know that it's hot. We know that it can be dangerous. So it's the lightning part that, of course, can cause the damage. The thunder is just a result of the lightning. The thunder is not going to hurt you. It may shake your house, it may rumble things, but the lightning is what does the damage, not the thunder. That's just a byproduct of the lightning, but it definitely gets our attention whenever we have thunder. I see people are coming on, wonderful. I'm glad to see you out there for StormTracker School. So today we're talking about how thunder occurs, why thunder occurs. So what you're going to need is a paper bag like this one. This is just a simple old lunch bag, a brown bag, if you're brown bagging your lunch. You may want to soften it up a little bit. It works a little better if it's a little bit, sorry, it's probably very loud, kind of softened up a bit. You want a good set of lungs with some hot air in them. I know I've got that. I've got a good set of lungs with hot air. I'm full of hot air. And then a way to pop the bag, which would be just your hands, or a balloon if you want to use a balloon. I have a balloon here, a way to pop it. So I have a little push pin here that I'm going to pop it with, because that also is kind of similar to the way an air parcel expands when it's hit by lightning. It heats up really fast and it creates a shock wave that then travels to our ears. So we're going to illustrate thunder with either a balloon or a paper bag. So those are your choices. If you happen to have one handy, kids, grab one and we'll talk about how thunder happens, right? So we know we had thousands of strikes on Sunday night when those storms moved through. And we're probably going to have thousands of strikes tomorrow. It's springtime. We're in the peak of severe weather season. And when we get lightning, such as this that you see here, hitting our downtown with these vertical strikes, those are the ones where when we get vertical strikes, you hear it immediately usually, as opposed to horizontal cloud to cloud that kind of rumbles around. So these vertical strikes, of course, if you are in these locations, extremely dangerous. But basically, lightning is electricity. It's like a waterfall or a torrent of electricity that just reaches down from the cloud to the earth, trying to make that electrical connection. So as the lightning occurs, thunder happens. So talking about thunder, why does thunder occur? Well, you're not going to have thunder without lightning. It's just a byproduct of the lightning as the lightning heats up that air very rapidly. So how are these sounds produced? Well, as the air is heated rapidly, it expands so fast, and that causes a shock wave to occur. And as that shock wave occurs, it travels through the air to our ears, where we interpret it as thunder. Very loud, booming, startling sound. So why does lightning strike before thunder? Why isn't it at the same time? Well, that's because lightning is made of light, right? And light travels almost 1,000,000 times faster than sound does. So the sound is going to hit you later on after the lightning, and the further the lightning is away, the more there is a delay between the lightning and the thunder. So if you see the lightning and you hear that clap immediately, that means that lightning is very close. And of course, whenever you hear thunder, you want to be indoors. That's the only safe place you can be in a thunderstorm. So let's go ahead and maybe make our first little lightning clap here. We'll see how I do. Just put the paper bag, not a plastic bag, kids, but a paper bag over your face, okay? Okay, that was kind of lame. I did a really good one the other day. That was so loud. Let's try it again, kids. Let's try it again. But first we have to put in the hot air, okay? So when lightning occurs, it causes that air to expand, okay? I'm going to soften it up a little bit. Soften it. That makes it expand a little better. So when lightning heats up the air, it causes the air parcel to expand. Like I'm going to make this paper bag expand as I blow it full of air, right? Okay, let's try it again. Okay, that was a pretty loud bang. I hope you heard that. So what happens as, just like this paper bag expanded, that air, when I released it by hitting it, a shock wave happened and it traveled through the atmosphere to our eardrum, where we interpret it as a bang, okay? So it's similar to the way thunder travels, or the sound of thunder travels through the air. We can do the same thing with a balloon. Do you have a balloon? I always love those clowns that used to come around to the restaurants and make little dogs and dragons and stuff out of balloons. It's fun. Okay, so here we go. We are going to talk a little bit more by showing you the air in a balloon. So imagine this is a parcel of air. The lightning just moved through it and it heated it up. That was my hot air that went inside this balloon. So then as the air gets heated, it creates a shock wave, just like this is going to create when I pop it. So here's my little push pin. Okay, so the lightning heated up the air, expanded it, and then when I pop the balloon, it's very similar. We hear a bang when we pop the balloon as the air moves through, as the sound wave, the shock wave moves through the air. So it just is kind of a neat sort of way to talk about sound waves and how they travel much more slowly than lightning travels. This was one of our StormTracker's pictures on Sunday night, showing the lightning hitting these downtown buildings. And this obviously is more of a vertical strike, but when you have a horizontal strike from cloud to cloud, that's when you can end up hearing that rolling thunder that we heard the other night. If it's rolling away from you, that's usually meaning the storm is moving away from you. If it's rolling kind of towards you and the sound gets louder, from quiet to louder, that means it's moving towards you. And of course, no matter when you have thunder, the only safe place to be, safe from the lightning, is indoors. So To sum it all up here, kids, thunder forms due to the rapid heating and cooling of the air, creating a shock wave that travels to our ears and we hear in the form of a loud sound. It creates a shock wave, a sound wave that moves through the atmosphere, and that sound moves at about 1,000 feet per second. And light moves 1,000,000 times faster than sound. So light is, boom, moving 1,000,000 times faster than the sound, and the sound arrives after the lightning. Since it is moving 1,000,000 times faster than the sound, it's going to take a while, the sound moving at about 1,000 foot per second. So if you want to know how far away the lightning is, you count. So crash, you see the lightning, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. That means that the lightning's about a mile away. If you hear boom, 1 Mississippi, that means that it's just right around the corner. It's literally less than a quarter of a mile away, maybe a fifth of a mile away. So right on top of you, and that's very dangerous. You want to be inside with the doors and windows closed, and even you don't even want to run the water in a bad lightning storm. You can actually get struck through your plumbing if the lightning bolt hits the pipes underground. So we're going to be talking about lightning safety tomorrow with severe storms coming. We do have that enhanced risk for severe storms, plenty of lightning tomorrow. So practice making your thunder sounds today, kids. I think your parents will love it. Thank you for joining me today for Weather School. We sure appreciate it for StormTracker School. And hopefully you'll join us tomorrow when we're covering these storms. And we urge all of you just to have a safe place to go, because it will be rather rumbly tomorrow, and we'll have that chance for severe weather with tornadoes, possible large hail, and gusty damaging winds. So it's always good to know a safe place close by where you can seek safe shelter if severe weather happens. So thank you for joining me today, everyone. And I hope you have a great day and stay safe.